Coding starting. Bismillahirrahmanirrahim. Achari, today we are going to discuss the November 23 P2 variant 2 theory paper it is. So let's discuss important question first of all. And for my side, I'm choosing the first one as to be question number 4, momentum. A ball Y moves along a horizontal frictionless surface and situations are given. Illustrated in movie. Before collision, ball has a mass, Y has the mass. This is the mass of Y. Initially moves along a line PQ, and the second ball has mass mz, not given, but is stationary. After the collision, the Y has final velocity, this given, Z has this, and the angles are given. Calculate the component of the final momentum of ball Y in the direction perpendicular to line PQ. This is a good question. Because indirectly it is asking something which we are not cannot find directly. पहले तो ये चले कि बेटा ये बॉल ऑब्जेक्ट y है जिसका मास ये है उस मूविंग विद वेलोसिटी. तो मोमेंटम क्या होता है? मास वर्सेस वेलोसिटी. कैन यू प्लीज शेयर द आंसर विद मी?
0.88 Newton seconds.
0.88 न्यूटन सेकंड्स. तो ये इसका मोमेंटम है. वेरी वेल आंसर. इसके दो कंपोनेंट होंगे.
Oh,
हॉरिजॉन्टल
sorry, sir. I already gave vertical component.
Okay. So I was thinking it was 0.9 something. Maybe. What was it?
Yes, the momentum is 0.93.
Okay. So this horizontal component will be original is 0.93 times cos 27, and the vertical component will be 0.93 times sine 27. Acha. So please can you tell me the answer of this and this both?
Vertical is 0.42.
0.42. Okay. And horizontal? 0.7 or 6 something?
0.82.
0.82. Is it? Okay. Acha beta ji. Now, for the Z object, it has mass this, velocity this. So mass times velocity, its momentum will be 5.5 mass mz. It will have a horizontal component that will be 5.5 mz times cos 44 degree, and vertical degree is component is sine 44. Actually, now coming to the question, it says calculate the component of the final momentum ball y in the direction perpendicular to PP. तो वो जो y का फाइनल मोमेंटम परपेंडिकुलर है वो 0.93 साइन 27, 2 मार्क्स का है. तो उसमें आई वुड रेकन कि आप उसकी पूरी वर्किंग शो करो कि पहले तो मास इनटू वेलोसिटी ले लें आप और फिर साइन ऑफ थीटा ले लें. तो mass is 0.25, velocity 3.7 है, and sine theta is 27 degree, and the answer is 0.4. फिर कह रहा है Considering the component of the final momentum of each pole in direction, calculate mz. तो बेटा देखो is the vertical component of y will be equal to the vertical component of z, so they cancel out each other, or the only resultant is horizontal. The initial momentum horizontal is the final be horizontal, the vertical component will be cancelled. So it means a 0.93 sine 27 degree will be equal to mz sine 45 degree, 44 degrees, sorry. So you know everything. आप mz find कर सकते हो. Can you suggest the answer, please?
0.11 kg.
Okay, जी बेटा. चलें अगले एक पार्ट तक. हसीब, चलें आगे. During the collision, the average force exerted on y by z is Fy, and the average force on z by y is Fz. Compare the magnitude and direction. Beta, both forces are have the same magnitude, but the direction are opposite according to Newton's third law. Right? Two blocks and they be moving directly towards each other along a horizontal frictionless surface. The block collides perfectly elastically. That is the most important hint. Before the collision has speed this, B has speed this given. After collision, the block B moves back along with the speed of 2. So beta, let's say this is M1, U1, M2, U2, and after collision, the B has speed. So B was mass 2, so its final speed is, and it moves back. So beta, we take now right words positive, then left one will be taken to be negative. So as it moves backward means it is positive, right? Okay. So formula, how would you find after the collision? And is there any hint about the masses?
No,
Okay.
sir.
No, beta, elastic collision, we have a formula. That is relative speed of approach is equal to relative speed of separation. This is the only formula where we do not need the masses, and it is only used for elastic line. So we know u1 is 4, u2 we will take it to be negative. This is the important point. The final speed is in positive for second, and the first one we have to find. So minus minus plus 10 and minus 10 subtracted from this, it will give us minus 8. But we do not need to write the minus because speed is a scalar quantity, and scalar quantity does not need to have sign or direction. Right, Vetani? Clear? चलें आगे.
Yes, sir.
Okay. A beam of vertically polarized. बेटा vertically polarized मैं बार बार कह रहा हूँ. Whenever it says ना vertically polarized का मतलब we have to take angle from the polarized vertical. अगर horizontally polarized होती था, theta will be taken from horizontal on a polarizing filter. ठीक है. और देखो जो पोलराइजिंग फिल्टर है उसका एक्सिस भी वर्टिकल है, तो इसका मतलब मैक्सिमम पास होगी. तो दैट इंटेंसिटी विल बी आई नोट मैक्सिमम. द ट्रांसमिशन एक्सिस ऑफ फिल्टर इज इनिशियली वर्टिकल. द फिल्टर इज देन रोटेटेड थ्रू एन एंगल ऑफ 360 पूरा राउंड. स्केच अ ग्राफ टू शो द वेरिएशन ऑफ द इंटेंसिटी. बेटा इस वक्त ये भी वर्टिकल है, इसका मतलब स्टार्टिंग इट विल स्टार्ट फ्रॉम द मैक्सिमम वैल्यू. अच्छा, अब हमारे पास लॉ है कि जो भी ट्रांसमिट होता है डिवाइडेड बाय ओरिजिनल आई नोट is equal to cos square of theta. तो अगर ना 90 डिग्री रोटेट करें, 90 डिग्री का मतलब ये 90 डिग्री भी मेंशन है, तो cos 90 जीरो है, जीरो हो जाएगा। अच्छा 180 है, हम यहाँ 180 रखेंगे, cos 180 -1 होता है, व्हेन यू टेक स्क्वायर तो वो 1 ही हो जाएगा, यानी आई नोट मल्टीप्लाई होगा तो आई विल बी इक्वल टू आई नोट मैक्सिमम। 270 cos 270 जीरो तो जीरो हो जाएगा, और 360 cos 361 होता है, यानी फिर मैक्सिमम। सो बेटा यू ज्वाइन and the answer will be this. Acha, only question could be there. A graph was to be a line or a curve. So square is involved. Better there it will be a curved graph. Right, beta ji? Clear? Ji Sadosh?
Sir, if it's 180 degrees, it's also maximum.
Yes, beta. Because square na, square of cos. Cos 180 degree has a square that is -1 cos 180 square will make it 1, and that was equal to I over I node na. So I over I node is 1, means the intensity transmitted will be equal to I node, which is maximum. Right, beta?
Okay, sir.
Okay. The intensity of the light in the incident beam is this. So this is the maximum intensity. When transmission angle is theta, the angle intensity beam is this. This is transmitted. Calculate the angle theta. So beta, there could be two possible values of theta. We have discussed in syllabus. Do you remember? I over I naught is equal to cos square theta. So I is 4.2. I naught is 7.6. Can you please share the value of 4.2 divided by 7 point?
0.55.
0.55. Okay. Beta ji, we need cos theta, so we will take square root of both. What will be the square root of 0.55?
0.74.
71?
74.
74. Okay, now cos square. There are two methods now. You can write both plus or minus with it, or you just take cos inverse, and whatever the answer will be, the other angle is 180 minus theta. Can you please tell the answer to this?
41.9 and 138.0.
49.9,
41.9.
41.9. Sorry. So if this is one angle, the other angle is 180 minus theta. So 180 minus 41.9 is the other angle. So they have, it is of two marks. What I suggest, you write both answers. Both are correct. If even you write one, they will accept it because there is no space for given, right? And it says only angle, not angles. What is meant by diffraction? Diffraction is spreading of a wave through a narrow slit or bending of a wave around a corner, right? The diffraction grating, straight away wavelength is given, the angle is given, the third order tells order number is 3, and calculate the spacing d. You know the formula n lambda is equal to d sine theta, and all the values are given straight away. 3, wavelength is 4.3 10 raised to power minus 7, D we have to find, and theta is 68 degree. Right, beta? I hope you can find. The next part can be a good one. If you allow me to go there, determine a different wavelength of visible that will produce a diffraction of maximum at angle this. First of all, what light it was. This is a beam of light incident, and let me tell you, this is we are having video, the visible light. What we have learned that the wavelength of violet is 315 nanometer. Nano means 10 raised to power minus 9. If you multiply minus 9 with this, it will be 3.50 10 raised to power minus 7. The red one has 650 nanometer. That can be 6.5 10 raised to power minus 7. Why I am converting into minus 7? Because this is given in minus. And the green is 500, means 5.0 10 raised to power minus 7. So you can see it is a little less. This is the minimum. So beta, it is going to be blue or indigo. This 4.3. Blue is the closest, very close to the 5. So beta, blue light, let's say it is. Now, it is saying def- determine a different wavelength of visible light that will also produce the diffraction maximum at night. We know this. We have to find the wavelength. What can that be? We have a formula, and lambda is equal to d sine theta. Beta, the d is same, the angle is fixed. Only relation is this n and lambda. And that can be the n dividing. But whenever we have to check the proportionality between two quantities now, we need them to be on either side of the equal. So I get this n here. You can move the wavelength as well. Now we can clearly see they are inversely proportional. So beta, as now we were having the wavelength initially that was very close to blue. So we are having more option for the other color on the right side, where the wavelength will be larger. And inversion means if we are to have a longer wavelength, then the order needs to be decreased. So initially we were having an order of third order here. So for having a longer wavelength, we need to have second order there. So beta, we will use this formula and put the second order. The D will be the same what we calculated. Can you suggest the answer, please? So we can use 3 multiplied by this divided by sine 60.
6.4 times 10 power minus 7. Oh,
6.4.
oh, sorry, for D is 1.39 times 10 power minus 6.
Okay, वैसे let me tell you, we could have written this same here. The answer would have been perfect. Okay, now you can find lambda. Can you please tell me the lambda? And we have to check. It may not be the answer that it is within visible or not. It is below 650 or 680 nanometer.
It's 640 nanometers.
Okay, that's good. So 6.4 10 raised to power minus 7, you are telling me. And yes, so this is possible. This is within 650. अच्छा अगर ये 650 से above होता ना तो it means वो visible नहीं होता. Then we had to think otherwise. वो क्या? फिर then we would have increased n by 4, and then the wavelength we had to check should be above 350. We are having more option to the right side, so we first chosen going to the right side. Right? Clear?
ये बताना एक ख्वाब देखेगा कोई अंकल नहीं जैसे आसमान को बचाया था उसको वो चाहते हैं कि प्लेन पे जाएगा आगे क्या होगा
Okay, done. Should we move to the next part?
सर ब्लू वाला भी करा दे
कौन सा?
सर गुब्बारे वाला गुब्बारा
अच्छा पहले इलेक्ट्रिसिटी वाला कर लें अगर आप इजाजत दो तो.
जी सर
ओके. कह रहा मेटल वायर हैज अ रेजिस्टेंस पर यूनिट लेंथ. पर यूनिट का मतलब है डिवाइड. Means this is resistance divided by length. Wire has a uniform cross section area A. Resistivity calculate करें. So resistivity is equal to RA over L. But what is here? We are given combined value of R over L. So we will separate it. You solve it. I hope it's done. Now, a battery of EMF and negligible internal resistance is connected in series with a fixed resistor, light dependent, you can see. A resistance of fixed is 1400 given, and the light intensity cause it have resistance. This voltmeter connected across, read this. So if this is reading 6.54 volt, so that the current in LDR is this. So we know voltage and resistance. Resistance कितनी है? 1600. You will get the answer. I hope you can do that. Next, calculate the number free electron passing through LDR in minutes this time. बेटा number of free electron capital है. तो फॉर्मूला होता है I is equal to NE over T. E की वैल्यू हमें पता है, टाइम की वैल्यू is given. We need N. Current will be taken from this क्योंकि current we have calculated and चलो उसकी वैल्यू ले लेते हैं. That is very close
Yeah,
to
it's
this.
exactly same.
हाँ. 10 raised to power minus 3. And we have to find E is elementary charge on electron, and T time needs to be in seconds. 3.2 minutes, and every minute is. Can you please solve it? Calculate the EMF. Now, this is a bit of part, no difficult. Beta, we have to find EMF of the source. We need know the voltage of this. Now we need to know the voltage of this. How would you find? They are connected in series. In series, we have voltage directly proportional to resistance. If 1600 is receiving a voltage of 6.4, then 1400 will receive how many voltage? Let's say X. So cross multiply, or better to take their ratio to be same. V1 over R1 is equal to V2 over R2. We use this formula, right? Can you suggest the value of X?
I got 5.6 volts.
Okay, 5.6 volts. Now, if this is getting 5.6 volt and this is 6 point, the EMF is the total voltage. Only two are connected here in series. So beta, the total voltage will be the sum of both of them. 6.4 plus 5.6 and 12 volt is the answer. Okay, ratio of power dissipated this. As we know, they have same current. They are in series. So we have three formulas for power dissipated: Vi I square R V square over R. We know the current is same and resistance is given. We know the voltage V square over R was. So we can use any of them actually. We know all V, I, and R. Twice is joules. Let me simplify. The currents will be cancelled if we use I square. The resistance is 16400, and for the other current is same, and the resistance is 14. So cancel, zeros cancel. 16 divided by 14 is the simplest answer. You can write it like simplified 8 over 7, or just solve it. 1 point what?
1.14.
1 4.
Yes, sir.
Okay, next part. The environmental conditions change, causing a decrease in resistance of LDR. Beta, LDR is inversely proportional to light. So when LDR decreases, means light has increased, and it means if there were clouds, they were scattered away, or if it was evening, now it's morning. The temperature environment doesn't change. State whether there is a decrease, increase, or change to the intensity of light, so light increases. Current in the battery. So beta, resistance decreases, overall resistance will decrease, the current will increase. Reading of voltmeter. As voltmeter is attached to LDR, so current increases and its resistance decreases. So this is not giving a proper answer. So we can get the answer from this, that there was an LDR which was connected to another resistance, fixed resistance, and total EMI was divided between two. So when I increases, this fixed resistance will get more voltage. So in a series circuit, the voltage is divided. If one part gets higher voltage, the other part will get low. Right, Beta ji? Now your favorite question, what was Hasib that? Hasib, this was your question.
जैसे मुझे लगता है वो ऊपर है, थोड़ा ऊपर ही है जी, सही है वाला।
A high altitude balloon is stationary. सारी forces cancel हो रही हैं. A solid sphere is suspended from this. The volume of the balloon is this. The total weight of the balloon and sphere is this. The upthrust acting on the string sphere is negligible. There is no upthrust.
तो मुझे लगता है इस तरह का आपने एक पेपर दिया था किसी टेस्ट में हमारे यहाँ, तो एग्जैक्ट सेम ये दिया था।
पता नहीं, I don't remember. Calculate the density of the air surrounding the balloon. Okay, beta ji. So beta, what do we know? वॉल्यूम हमें गिवन है उसका बलून का, टोटल वेट, और उसमें क्या कि स्ट्रिंग और सफियर पे जो लग रही है वो बस इस पे लग रही है अपथरस्ट। तो अपथरस्ट का फॉर्मूला क्या होता है? रो जी बी। अच्छा नाउ लुक, देखो बेटा, कोई भी ऑब्जेक्ट अगर हो रही स्टेशनरी है तो डाउनवर्ड फोर्स वेट विल बी कैंसल्ड बाय अपवर्ड फोर्स, दैट इज अपथरस्ट। अच्छा, ये जो अपथरस्ट नेग्लिजिबल थी वाज ओनली फॉर स्ट्रिंग एंड सफियर, बलून पे लग रही है। So their upthrust force will be equal to the weight, and the total weight is 65. The density we have to find 9.8, and the volume is 7.5. Right, Beta ji? String breaks, releases the sphere. Okay, Vidaji. The string breaks. Can you hear me clear?
Yes,
जी
sir.
सर
State the magnitude of acceleration. Quick, there was a message I had to see. Sorry for making you wait. State the magnitude of the acceleration of the sphere immediately after the spring breaks. It means when the spring breaks, the only force acting will be a thrust, and you have to find force is equal to ma, and means then the initial force. Okay, this is asking about sphere. So the force which is making sphere to move downward after it is broken. Let me answer the person sending me message again. Okay, so Bedaji, sorry to make you wait. Sphere has the total mass, balloon and string, sorry, and the total weight of balloon, string, and sphere is this. So that was the total weight of all the things. Calculate the density of air surrounding the ball we have done. The string breaks, releasing the sphere. Say the
Sir, can I
magnitude of
suggest
acceleration.
something?
But that is the gravitational acceleration. Is it?
Yes, in my opinion, it should be gravitational
Right, it
acceleration.
is of only one mark means no more acceleration is required. Because when string breaks, it will only be having gravity. Acceleration due to gravity is this downward. State and explain the variation, if any, in the magnitude of acceleration severe when it is moving downward before it reaches terminal velocity. So, beta, we have to tell the magnitude. Beta, for every object which is going through terminal velocity, we have a graph like that. Here, acceleration is 9.81, and this curve down tells the acceleration decreases until the acceleration becomes zero. So, beta, we have to tell it is of 3 marks. So, initially, the acceleration will be 9.81, and as the object starts increasing speed increases, the acceleration decreases due to increase in the drag force. And a time comes when the drag force becomes equal to the weight, then resultant force and acceleration both become zero, and the object reaches a terminal velocity with zero acceleration. So acceleration will decrease from 9.81 to zero. Right, beta? There will be three stages. So initial acceleration was 9.81, and as the speed increases due to drag force opposing the movement, the acceleration decreases until the drag force becomes equal to the weight, and then resultant force and acceleration both become zero. Right, beta ji? Clear?
Yes, sir.
Okay. The sphere has a mass. Calculate the total resistive force when its acceleration is this. So beta F is equal to ma, acceleration is given. The backward force mg and resultant drag force is we have to find this drag force. And in F is equal to ma, F is the resultant force. As it is moving downwards, accelerating means this force is larger. So mg larger force will subtract the smaller force, substituting the values. Now I hope you can calculate. Any other question? See,
नहीं सर.
the question I remember ना that was कोई सर्फर था जो पानी में मूव कर रहा था बोट के साथ, उसके साथ एक पैराशूट था, वो दैट वाज अ बेटर क्वेश्चन. So can that be all for today? What do you think?
Sir, I have a question.
जी जी बेटा बोलो.
Question 3, Part B.
Question 3 part B and
Part D. Last.
part last part. 3 है हमारे पास स्प्रिंग है, ठीक है. The mass spring of mass is able to slide along the full length of the road. ठीक हो गया. First push against the surface. Initial compression, the spring is then suddenly released. So आगे जाएगा, ऊपर जाएगा. Assume the spring obeys Hooke's law. Initial elastic half k square half f square. Calculate the spring. Spring constant was given. ठीक है. With the kinetic energy. So elastic potential energy, kinetic energy की equal है. You will use formula half k square to find k, and this is the energy, and that should be equal to data. I'm just looking for the parts before now doing going to the last part. I haven't seen this question. Calculate the speed, kinetic energy आगे तो आप mv square रखेंगे. C rises to maximum height up to this. This causes gravitational potential energy to increase by this mgh. Increase in height mgh के को रखोगे इसको, you will get the h. Calculate the average frictional force. Okay, this is this was the better part. Take loss in kinetic energy will be equal to gain in gravitational potential energy plus work done against friction. And work done against friction is frictional force multiplied by the height. Okay, this is the part you were asking. The road is replaced by another road that exerts negligible friction. No friction. The initial compression x of the spring is now varied in order to vary the maximum increase in. ठीक है. Assume that the spring obeys Hooke's law for all compression. Sketch a graph to show the variation with x. X is the compression. The numerical values are not required. So, beta, if you compress more, one thing, if you do not compress, it will not go to any height. So, the first point should be there. Right, beta ji? And if you keep increasing, so what the relation we are having? We are having the elastic potential energy converted into gravitational potential energy when it rises. When we compress, the elastic potential energy is equal to half ke square. Is it? So now we are using, okay, if we remove all the constant, there is a relation of x square is equal to h. And beta, when there is a square relation, it is curved like that, upward curve. Right, beta ji? As we know, y is proportional to x square. Y is the h is on the y. We have a graph like that. Right, beta ji? The answer is this. Clear, Surosh?
Yes, sir.
Can that be fine? Do you understand? Any other question?
No, sir.
Okay, let just wait